Assalamualaikum warahmatullahi wabarakatuh. My name is Iden Bardan Bayunugraha from Sunan Kalijaga, Yogyakarta, majoring at informatics. At this occasion, I want to share to you guys about the discrete mathematics chapter 3 with the topic tree traversal. So, traversal is a method to visit all the nodes from the trees and may print their values too. There are three ways or methods that we can use to traverse a tree. The first one is the pre-order traversal, the second one is in-order traversal, and the last one or the third one is post-order traversal.
So the first thing I want to explain is the pre-order traversal. This traversal method, the root node is visited first, then the left subtree, and finally the right subtree. Let's use this tree as an example. From the pre-order traversal, we'll get this algorithm, and if we use the algorithm to traverse this tree, we'll get the result as like this. But how do we get this? So I'll try to explain that. We need to use this algorithm for each of the nodes. To make it easier for us, let's just write right beside it. So the very first thing we need to visit is the very first root node in this tree. So we go to the A and do all the steps. The first one is visit the root node. So we have to visit A, then we get the result. After that, do the second step, which is visit the left subtree. Then we go to the left subtree, which is B, and do the steps for the B node, which is the first is visit the root node. Then we visit the B and we'll get the B as a result. And after that, let's go to the left subtree. We will get D and do as like before. Visit the D, we get D. And for this problem, this node doesn't have left subtree, either right subtree. So let's just skip this step. And because all the steps are done, we need to go back to the root tree and continue the steps on each node. So we have to go to the right subtree. We'll get E, and as like before, it doesn't have left subtree or right subtree. Then we get back to the B, and all the steps on the B nodes are done. So we move back to A, and A still have one step, that is visit the right node or right subtree. So we go to the right to get C, then visit the node, we get C, and go to the left subtree. We'll get F after visit the node. Same like before, this node doesn't have left subtree, either right subtree. We move back to the C, and this node doesn't have right subtree, so we'll get the full result. And the second one is in order traversal. So in this traversal method, the left subtree is visited first, then the root, and later the right subtree. Let's use the same tree as before as an example, and we'll get this algorithm from the in order traversal, and using the method we'll get this result. So how do we get that? Let's just use the same method as before. Let's write the algorithm or the steps beside on every node. So first, visit the very first root node, which is A, and then do all the steps. First we go into the left subtree, then we go to the B and do the steps on each node. We go into the left subtree again and we'll reach D. In this subtree, it doesn't have any left subtree, so we just skip this step and do the second step, which is visit the root, and we will get the result D. And this node doesn't have any right subtree too, so we'll skip these steps and get back to B. Continuing the steps, we need to visit the root, so we'll get the result B, and then go to the right subtree. On its right subtree there is E. Do the steps, go to the left, but there is nothing on its subtree, so we'll skip this and visit the root subtree. Then we get E. Same as the left subtree, it doesn't have any right subtree. Skip this and get back to B, and because on the B all the steps are done, get back to the A, and then continuing the second step to visit the root node. Then we'll get A. And after that, let's just keep continuing like what I had said, so you will get the full result as like this. And the third one is post order traversal. So in this traversal method, the root node is visited last, and then we visit the left subtree and the right subtree. So it's the same tree, and do the method as I said before, and I will let you do that work to have a try. And if you already have tried it, I will show you the results. So here are the results. And here I have a problem that you can try to getting it done. You can pause the video first and getting it done, and I will show the answers later. So here are the answers. First, we get that this in order expression and this pre-order expression. Let's just convert it as a tree. And because we asked to get the post order, so let's use the post order method, which is left and then go to the right subtree and then visit the root node. And after you do this method, you will get the result like this. And now I will try to explain what is infix, prefix, and postfix notations. So we can represent complicated expressions such as compound proposition, combination of sets, and arithmetic expressions using ordered root trees. For instance, consider the representation of an arithmetic expression involving the operators addition, subtraction, multiplication, division, and exponentiation. We will use these parentheses to indicate the order of the operations. So the first one is infix. For example, we have an expression as below, a plus b. This type of notation is referred to as infix since the operator, that in this case is an addition, is in between the two operands that is working on, which is a and b. So consider another example, a plus b multiplied by c. The operators addition and multiply still appear between the operands, but there is a problem. Which operands do they work on? Does the addition work on a and b, or does the multiply take b and c? The expression seems ambiguous, so we need to add parentheses. And the second one is prefix. Prefix expression notation requires that all the operators precedes the two operands that they work on. Consider the infix expression is a plus b. The prefix expression will be plus and then a, then b. And the last one is postfix notations. On the other hand, this postfix notations requires that its operators come after the corresponding operands. Consider the infix expression is the same as before, that is a plus b. The postfix expression will be a and then b, and the last one is the plus one. To make it a little bit easier, we can convert infix expression into binary trees. So the example before is a plus b, and we can convert these expressions into our binary trees like this. After that, we can use the binary trees and use the pre-order method to get the prefix expression and post-order method to get the postfix expression. So here are the binary trees that we get before, and we can use the pre-order method to this tree to get the prefix expression and use the post-order method to get the postfix expression. And here are the prefix and postfix. If we get infix expressions that have parentheses on it, so when a plus b was written in prefix, the addition operator was simply moved before the operands, which is plus a and then b. So the full prefix expression will be, the first one is the multiply and then the additions, and after that the a, b, and c. Likewise, in postfix a, b plus forces the additions to happen first. The proper postfix expression is then a, b plus c, and the last one is multiply. And here are a table for some other examples. And after we get the prefix or postfix expression, we actually can get to calculate the value. How do we do that? So for the prefix expression, we start from the right side of the expressions and find the nearest operators. So like using the pre-order method, first we go from the middle and then the left one and then go to the right one, so we get this expression. And for the postfix expression, we start from the left side of the expression, and using the post-order method, we first go to the left side and then the right side and then go to the middle and get this expression. And after that, we can get the full value from the expression. And here are the example from the problem. You can pause the video and get it done, and I will show you the answers later. So here are the answers. First, we convert it into a binary tree. Here are the binary tree. And the second step is use the pre-order method because we are told to get the prefix expressions. The pre-order method are visit and then left and then right. Then do the pre-order method to the trees and you will get the result as like this. If you haven't understand it yet, you can try to find all these references that I got. I think that's all that I can share to you guys about the tree traversal. I hope you guys can understand it very well, and if there is any mistakes from me, I would like to say sorry. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.